Alright, this is a code review for the vector calculus project. Um, let's get started. I don't have Visual Studio on my desktop, so I'm going to be using these files in my Google Drive. We're going to start out with the weapon frame, just to get an idea of what the data types and stuff is. So this is a class for the M4A1 Remington. It inherits from an interface frame. The data that it has is a double velocity. Double just means that it can do, the data type can store decimals. And it does that with these 5 data types. In the public, we have the essentially the default constructor. What it does is it just creates the class or the object that holds these 5 data types. And then all of these are getters for the data types. So it gets the data for the velocity, drag, mass, cross-section, and cross-section Y. This code is the code for the constructor, and that just tells it what to fill out when the object is being called. Okay. Moving to builder, this is where the main chunk of the math and everything is in. The builder has a standard constructor where it takes in the what gun is going to be put into it. It has the find start angle, which I'll get to later, but it returns a double, which again is a integer with a decimal. Wind adjustment, it returns a double as well. It takes in the distance, the wind, and the wind's direction. And then a long double to find the x angle. That is basically saying that this is going to be either a very big number or a very small number with decimals. And this finds the angle in the x direction. It takes in the angle and then the distance. It is a recursive function. And then these two, print and demo, which demo I used for getting a random set of integers to put into the functions, and for print, it just prints out the data. This is the constructor. We set the time equal to 0, and then we have a switch statement for the gun. If a M9 is passed into it, then it will get the data from the M9 and put it into the data for the builder. And same with the M4A1 and the M40. Moving on to the find the start angle. Const double part 2. This is the second part of the equation, so I can call it later in the main equation. So it is the square root of velocity to the 4th minus gravity times gravity times distance squared plus 2 times the velocity squared. And then we put that in a arctangent with velocity squared minus part 2, which is the function that I said just a second ago, and then divide the entire thing by 9.8 times the distance. And then this returns the angle. It doesn't necessarily... The thing with this function is it doesn't need to be 100% correct. It just needs to be close enough or accurate, because the function that I put that into calculates it already, or it doesn't care about how much it's off by because it will find it automatically. For the wind adjustment, I take the wind force, so yeah, the force of the wind, and I divide it by 1,000, and then I divide it by 60. This is to get the wind force in meters per second rather than kilometers per hour. Then I take the wind in the z direction, which is essentially taking the wind from the left and right, because from what I saw, the bullet will negate any wind coming from the front or back, or it won't negate it, but it won't matter in the long run. So we only care about the wind in the x and y direction, or the x direction. Then this is if statement. If time is equal to 0, then it's going to call the find angle x, just so we can get a value on the time. And then we take the z displacement by multiplying the wind in the x direction times the time. And then the return statement returns arctan displacement over distance. Moving on to the x angle, we start out with having the x position and the y position. The y position is based on the average height of the human. T is the time. We set it to equal 0. The dt is the number of instances that I want to calculate. D is drag. That formula is 1.225, which is the air pressure times the drag or the ballistic coefficient of the gun times the cross section in the x direction. And to get the velocity in the x and y direction, I multiply the velocity times the angle and the cosine angle, and velocity times sine angle. And I set the velocity equal to the velocity, the muzzle velocity of the gun, because I do that because that velocity is going to be changing during the following while statement. So this while statement states that while the position in the y is less than or equal to 1, so if it is below, or it will break the while loop while the y is less than 1, basically what I said. We increment time based off of the dt, so time plus dt while it's going through this while statement. Acceleration in the x direction is equal to negative drag over the mass of the bullet times the velocity in the x direction. The acceleration in the y direction is equal to negative gravity minus drag over mass times velocity in the y direction. The following functions are to get the new velocity for the x and y directions, which is found by taking the current value for Vx and Vy and multiplying it by the acceleration times the dt. And the same with the velocity in the y direction. It's the same formula. To get the x position, it is the following statement, which is the current x plus the velocity in the new direction, the velocity in the new velocity times the dt plus 0.5 times acceleration in the x direction times dt squared. And y The same can be said for the y. Then we put the new velocity into the old, we overwrite the old velocity with the new velocity and update that data here. And then the velocity is equal to the square root of the velocity squared plus the velocity in the y direction squared. The velocity in the x direction squared and the velocity in the y direction squared. So that will get the total velocity. Then I put the acceleration in the x direction into a class called storage. That just stores the acceleration, the velocity, and everything that this is calculating, and as well as the velocity. And this will be updated every time it goes through this while loop. So after the bullet's y direction is less than 1, it will stop doing this calculation, and the final acceleration in the x direction and the velocity in the x direction will be put into storage, or yes, will be put into storage. Then we set the time of the data type to how long it took, and then we calculate the off-by distance by taking the target distance minus subtracted by the current's x position. And then this increment is used for determining the angle that we need to adjust by, and then also storage is off-by is stored into the storage class. This if statement says if off-by is at least 1% within the target distance, then it will put the angle into the storage class and return the angle. Otherwise, it will call this function that we're in right now again, but it will increment it by the increment, which is 0.0001. But if it's above the target distance, or if x is less than the target distance, it will adjust the angle upward. If it is below the target distance, it will adjust the angle, the increment downward. The following code just sets random variables for the data entered, so that way I could test it to make sure that most cases are good to go. This is also what I used for the demo for the presentation. And then this print function can take in user-dependent data. I'm going to move on to the storage class just so you can see what's in that. Essentially, it just stores the acceleration in the x direction, the velocity in the x direction, the acceleration in the y direction, the velocity in the y direction, the velocity total, and the off-by, as well as the angle. All of these are getters and setters, so it sets and gets the data from this class. That is basically the full rundown of the code. It seems to work correctly. The only, if I had to put my finger on something that is wrong with it, it would probably be the wind adjustment, but again, this isn't necessarily the easiest thing to test or to make sure that it is 100% correct. But I'm glad I did it. I learned a lot from trying to figure this out, as well as using the math functions inside code. Alright, that's basically the rundown for this code. Thank you for listening. That's all.